In this video, we'll see how to add and subtract irrational numbers. To add or subtract two or more square roots with the same radicands, add or subtract their coefficients. The answer is the sum or difference of the coefficients multiplied by the common radical. Let's see an example. 2 square root of 3 plus square root of 3. We have to add two square roots with the same radicands, 3. So we have to find the sum of the coefficients. The coefficient of the first square root is 2, of the second is missing, it means it's 1. So we add 2 plus 1 and multiply the result by the common radical. The answer is 3 square root of 3. We can think that this is a problem for adding, or it could be for subtracting the same items. Let's say our item is square root of 3, so I have to add two items and one item, and the result will be 3 items, and the item is square root of 3. Let's know how to add and subtract radicals with different radicands. Simplify 5 square root of 3 minus square root of 12. These radicals cannot be added because they contain different radicands. The first radicand is 3, the second is 12. When this occurs, determine whether one or more of the radicals can be simplified so that they have the same radicand. The first radical cannot be simplified, but the second can. 12 has a factor that is a perfect square. This is the greatest factor that is a perfect square. So square root of 12 can be expressed as square root of 4 times 3. And now we can apply the product property of radicals. This single square root will equal to product of two square roots, square root of 4 and square root of 3. Square root of 4 is 2, so we get 5 square root of 3 minus 2 square root of 3. Now both radicals have the same radicands, so we can subtract them by simply subtracting their coefficients. 5 is the coefficient of the first radical and 2 is the coefficient of the second radical. The result is 5 minus 2 times square root of 3 or 3 square root of 3. Let's do one more example. Simplify. 13 square root of 2 plus 2 square root of 18 minus 5 square root of 32. We can't directly add and subtract the radicals because they have different radicands. All of them are square roots but with different radicands. So we should try to simplify the second and the third radical. My advice is to stop the video at this moment and to solve the problem by yourself. And then you can watch it and compare the results. We can simplify square root of 18. 18 has a factor that is a perfect square. The greatest factor that is a perfect square is 9. So we can express 18 as a product of 9 and 2. For the next radical, we're looking for a factor of 32 that is a perfect square. And it will be 16. 32 is a product of 16 and 2. Now for the second and the third radical, we can apply the product property of radicals. Square root of 9 times 2 will equal to square root of 9 times square root of 2. And square root of 16 times 2 will equal square root of 16 times square root of 2. Square root of 9 is 3. Square root of 2 cannot be simplified further. Then we have minus 5. Square root of 16. Square root of 16 is 4. So I get minus 5 times 4 times square root of 2. Square root of 2 also cannot be simplified further. So multiply the coefficients of the second and the third square root. And we get 13 square root of 2 plus 2 times 3, 6 square root of 2 minus 5 times 4, 20 square root of 2. Now we can add and subtract those radicals because they have the same radicands. So we simply add or subtract their coefficients. 13 plus 6 minus 20 times square root of 2, or minus square root of 2. And this is the final answer. Let's see now the following example. Simplify square root of 2 plus square root of 3. Both radicals cannot be simplified and they don't have the same radicands. So we can't add them, and the answer is that this expression cannot be simplified further.